Welcome to Quick MCAT Lessons, where I try to explain MCAT topics in 10 minutes or less. Today, we're going to start chemistry. We're going to be starting with the atomic structure. So when we talk about atomic structure, it all starts with subatomic particles. These are the tiny particles that make up an atom. There are three main ones you need to know: protons, neutrons, and electrons. Let's start with protons. Protons have a positive charge, and each one has a charge that is equal to the fundamental unit of charge, which is E is equal to 1.6 times 10 to the power of negative 19 coulombs. We denote this as a charge of plus 1 E, or just plus 1, which is what we see on the elements. Now these are found in the nucleus. The nucleus is a dense center of the atom. Protons are pretty hefty, relatively speaking, and their mass is about 1 atomic mass unit. This is kind of the standard we use to measure things on the atomic scale. And just for reference, 1 atomic mass unit is 1.67 times 10 to the power of negative 27. Now, what's really important about protons is that they tell you what element you're looking at. So for example, if an atom has 1 proton, it's hydrogen. If it has 6 protons, it's carbon. The number of protons is called the atomic number, and it's denoted as Z. This is unique to each element. Next up are neutrons. Like protons, neutrons are also located in the nucleus and they have a slightly higher mass, but for our purpose they're the same. So I said protons have a mass of 1.67 times 10 to the negative 27. Neutrons have a mass of 1.675 times 10 to the negative 27. So just slightly bigger. Now, unlike protons, neutrons have no charge. They're neutral, hence the name neutron. Now, the main job of neutrons is to add mass and help stabilize the nucleus. If there are too many or too few neutrons compared to protons, the atom might become unstable or radioactive. And so atoms of the same element, which means they have the same number of protons, can have different number of neutrons. These are called isotopes. So for instance, carbon-12 and carbon-13 are both carbon as they both have 6 protons, but carbon-13 has 7 neutrons, which is 1 more than carbon-12. Every atom also has a mass number. This is the sum of neutrons and protons in the atom's nucleus. You'll typically see the mass number on the top left of the element symbol, and the atomic number will be below it. And so now for electrons. Electrons have a negative charge, which is equal in magnitude to the proton's positive charge, so the electron's charge is -1. But these electrons are incredibly light, and their mass is about 1 over 2,000 of a proton. And so for most purposes, we say their mass is negligible. And so the number of protons is equal to the number of protons. And we know the number of protons from the atomic number. And so they're equal in a neutral atom. But if there's a charge, you must take that into account. And so if there's a +1 charge, you have 1 electron less. And if there's a -1 charge, you have 1 electron more than the protons. No, electrons aren't in the nucleus. Instead, they exist in what we call the electron cloud. This is the space around the nucleus where electrons are likely to be found. Electrons move around the nucleus at varying distances. Electrons closer to the nucleus are at lower energy levels or in lower shells, and those that are further out have higher energy. And the electrons that are further out have the strongest interactions with the surrounding environment and weakest interactions with the nucleus. These are called the valence electrons. Now, in a neutral atom, the number of protons equals the number of electrons, so the positive and negative charges cancel out. But if an atom gains or loses electrons, it becomes an ion. Losing electrons gives you a positive ion, or a cation, because you're losing a negative charge, so you're becoming more positive. On the other hand, gaining electrons gives you a negative ion, or an anion, as you are gaining a negative charge. So we talked about how isotopes have the same atomic number, but a different mass number, which means that they have the same number of protons, but different the number of neutrons. Now, almost all elements exist as 2 or more isotopes, and these isotopes are usually present in the same proportions in any sample of a naturally occurring element. And so if you take these different weights and average them based on proportion, you will get the atomic weight. This is the number that you see on the periodic table. So, for example, chlorine has chlorine 35 and chlorine 37. Chlorine 35 is 3 times more abundant than chlorine 37. And so chlorine's mass number is 35.5. And there are also things called isobars. These are atoms of different elements that have the same atomic mass, but different atomic numbers. So an example would be carbon-14, which has 6 protons and 8 neutrons, giving it a mass number of 14. and nitrogen 14, which has 7 protons and 7 neutrons, giving it a mass number 14. There are also allotropes. These are different structural forms of the same element in the same physical state. So an example would be graphite and diamond. They are both solid forms of carbon, but very different. Another example is ozone and dioxygen. Both are forms of oxygen and have different chemical properties and roles in the atmosphere. Now let's talk about atomic weight again. So the atomic weight is the mass of 1 mole of the element in grams. Now what's a mole? A mole is a number of things, like atoms, ions, or molecules, that are equal to Avogadro's number, which is 6.02 times 10 to the power of 23. So carbon's atomic weight is 12.0 AMU, or atomic mass units. This means that 6.02 times 10 to the power of 23 carbon atoms have a combined mass of 12 grams. Or 1 mole of carbon has a mass of 12 grams. And we'll talk more about this when we talk about stoichiometry. And now that's it for today. Next time we'll talk about some atomic theories.